FPGAs have been another aspect to help engineers compute the data sets that they need, as well as control their DUTs in a very effective and very performant manner. And now we're seeing LabVIEW, like I just mentioned in the instrumentation future, really enter a new age of web and cloud and connectivity and how all of those come together. And so it's been an exciting history of LabVIEW. Certainly couldn't capture it all in one very concise answer, but I think those three milestones, multi-core processors, FPGAs, and now web and connectivity are some key things that LabVIEW makes accessible to engineers over the years.
And what benefit does multi-core processing after for engineer creating test systems?
Yeah, so multi-core, so now picking off multi-core off the evolution of LabVIEW. So multi-core was introduced in LabVIEW over 10 years ago. So as multi-core processors came out, again, it was a challenge for engineers because how do you program multi-core processors? How do you manage threads and other things that aren't for a normal engineer, a mechanical engineer, maybe a domain expert in chemistry? Those aren't natural things that come to them. So how can they make use of these latest technologies? LabVIEW really provides that abstraction layer to allow them to use it. Now, graphical programming, so LabVIEW's graphical programming, dropping down blocks and data flow semantics, right, to execute code, that naturally enables parallelism. And so you can have multiple rows of blocks with while loops. That concept, it was introduced even before multi-core processors came out, but that concept enables engineers to very quickly relate to, and LabVIEW actually maps it to multi-core processors. So you may have two loops here running on your LabVIEW code, you build it up. LabVIEW compiler is smart enough to actually map those to different processors or processing cores on a single computer. So the final advantage of that is really task parallelization. So more tasks can execute for an engineer in the test or measurement application they're building, as well as computational or analysis parallelism. So LabVIEW enables them to crunch more data, right? Do more analytics and fully utilize the cores that they have, whether it's 4 cores, 2 cores, 8 cores, where typically in text-based programming that would be much more difficult. You'd have to know and have computer science background to do it.
What step is NI to ensure the student gets the SS?
Yeah, so for students, I mean, LabVIEW has been a key component of the bench, not only industry bench, but also student bench. And so there have been a number of products that we've introduced alongside LabVIEW to ensure that the students can learn through real-world experimentation, actually doing engineering. And so LabVIEW has provided many avenues to do that in the lab setting as well as the classroom setting. The most recent of which is the Elvis 3 release at this NI Week, where it's the latest next generation platform for us for lab measurements, so that students can focus on project-based interactions and do that through instrumentation interfaces, FPGA-based interfaces, as well as web interfaces, all of which can be interfaced through LabVIEW. So certainly that product platform is important, as well as our commitments through things like academic site licenses and student versions of LabVIEW to make it financially possible for them to access the tools as well.
What RIO?
Sorry?
RIO.
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 Oh, the Rio?
Yeah.
In regards to the My Rio?
What helps the engineers?
Yeah, so so the Rio platform and how it helps engineers. So for us, just to quickly talk about the Rio platform, it consists of a processor and an FPGA, both programmable with LabVIEW that's connected to I/O. And so it comes back to the problems that we see in automated tests and automated measurement applications are increasing complexity. And one way to address that is by using this flexible architecture to utilize an FPGA when necessary. So if an engineer would need to do very tight or quick closed loop control, they have access to an FPGA to do that and the abstraction of LabVIEW. Likewise, they have access to a processor which can do file storage, do analysis, they can reuse maybe Python within the processor. Again, all with LabVIEW as the abstraction layer so that they don't have to architect an application and actually build up a processor on a custom board alongside an FPGA and I/O. Rather, we provide a software-defined platform that LabVIEW is a key part of and Rio technology is a key part of to enable engineers to automate their measurements and create test systems more efficiently.
What are new generation technologies?
Yeah, so for LabVIEW specifically, I'm really excited about, again, last NI week we released 2 versions of LabVIEW into market. This is the first time we've ever done it in 30 years, so it's been a really exciting year for us and for our customers. But our next generation technology is really focused on ensuring that the future of LabVIEW is bright. And so those technologies that I'm excited about, both in LabVIEW and LabVIEW XG, include web technology, so I mentioned that before. The ability for engineers, again, if you want to create a web page that you see on your mobile phone or the phone that you have in front of you, that takes a certain level of expertise in HTML, CSS, JavaScript, all of these things that web professionals know, but engineers, mechanical engineer, domain expert don't know. And so we've invested in LabVIEW XG actually to enable engineers to, in a drag and drop fashion, create a VI, or a virtual instrument, that actually can be fully executed and run directly in a web browser. Right, and that web browser could live on your phone, could live on a tablet, could live on a PC. And so it's a really exciting technology to enable them to create remote interfaces and get more efficient about how they do their engineering tasks day to day. So that's one I'm especially excited about.
Yeah. What is the challenges? What is the challenges about test and measurement?
Yeah, so some of the key challenge underlying, if you're talking 5G, if you're talking some of the automotive challenges around electrification as an example, any of these megatrends, IoT often, or Industry 4.0 is often brought up. The underlying challenge is the complexity, right? Complexity of what's expected of that test engineer. And what's expected is to look at the DUT in front of them and keep schedule for all of the different DUTs that they're working on smaller and smaller teams. And so some of those challenges that then come out of the higher level challenge of complexity are things like, how do I better collaborate? It no longer is possible for one engineer, in most cases, to work alone to solve a test or measurement challenge. They have to work in a collaborative way, and software has to enable that. Likewise, I come back to what I said before, right, around the diversity of I/O. No longer are they working just on a DC signal or digital signal or an RF signal. We even saw on the keynote stage this morning where in the hearing aid, right, of their chips now incorporating RF and analog signals and digital, right? And so that complexity of diverse signals coming together, again, becomes a software challenge, as we talked about before, to unify all of that together, because ultimately those different signals need to coordinate and correlate together. And to do that in a traditional way either requires manual processors stitching together complex software pieces. So those are a couple challenges that I see personally is again that the 2 different complexities I mentioned.
What are the new innovation in design in 2018?
I think for us, we're excited about innovations that really span the area of software. Again, I'm from the software arena, so I'm biased. But traditionally, when we talk about software national instruments, we're talking about LabVIEW, and LabVIEW really spanning the entire product development process for an engineer. And certainly we'll continue to do that with LabVIEW 2018 and the new features, but also incorporating new software products that really focus on a certain task an engineer is trying to do. So for example, FlexLogger, new innovations in FlexLogger to enable configuration-based data logging without having to program, and allowing that to be interoperable and extensible with LabVIEW. Likewise with System Link, so the challenge of IoT, many devices deployed, many testers. How do you solve that? System Link we introduced this year for systems management, so that's another key innovation for us. And then finally, Instrument Studio. So if you need quick measurements from sophisticated instrumentation in one location, back to what I was talking about around the diversity of I/O, Instrument Studio provides that free software that comes with our modular instruments to do that, to see all your signals, to correlate them all in one place, save off the configuration, be more efficient in the rest of your workflow as an engineer. And so really the center of our innovation focuses on the engineer's workflow that they have within their job in validation, in design, or in production to make them most efficient.
And what are the what is autonomous? You are working on autonomous car also?
Yes. So as far as autonomous vehicles, we see a lot of test challenges around autonomous vehicles to ensure that as these different components of autonomous vehicles are deployed, that it is a safe and secure deployment, right, as they go through testing. And so for us, we've been focused, again, I'll bring it back to software. Within LabVIEW, we've been focused on providing best-in-class tools around LabVIEW and things like Veristand, which is our HIL kind of test cell software that works alongside LabVIEW to ensure that our customers can best keep up with the rapid change that's occurring around all the different components of autonomous vehicles. So you've heard some throughout the keynote stages of the ability to get to time to market quickly. You're going to hear actually in the keynote here in a little bit more of some of the challenges, and I'll just echo that software is a key component, and we've seen many engineers at National Instruments use our tools to be successful in getting to market more quickly, prototyping and doing those tests and the test coverage necessary to ensure they meet regulations for their components of autonomous driving.
And